uncovering the truth behind the Vikings' lost navigation stone the North Atlantic. It's a vast, unforgiving expanse of steel gray water where storms can pop up out of a clear sky and fog can swallow the world in a heartbeat. For centuries, this ocean was a barrier, a no man's land that kept continents apart. To sail into its heart was to sail right off the edge of the known world. And yet, one group of people looked at this death trap and saw a highway. Long before the age of exploration, before magnetic compasses were a thing in Europe, and way before the detailed maps we all take for granted, the Norsemen, the Vikings, made this terrifying ocean their own. In open-topped wooden ships, with a single square sail and the power of their own arms, they pulled off the seemingly impossible. They built a trade network from the rivers of Russia to the coast of North Africa. They colonized the remote volcanic island of Iceland. From there, they pushed even further west, settling the immense ice-locked wilderness of Greenland. And from Greenland, they sailed again, becoming the first Europeans to set foot in North America, almost 500 years before Columbus. These weren't short little trips from one friendly port to the next. The journey from Norway to Greenland alone was over 1,600 miles, much of it across a featureless, open ocean. They dealt with storms, icebergs, and the constant fear of getting lost. A single mistake in navigation didn't just mean you were late. It meant starvation, freezing, and a lonely death in the deep. Which brings us to the great enduring mystery of the Viking Age. How on earth did they do it? How do they navigate with such incredible accuracy across some of the most difficult waters on the planet? Picture this. You're a Viking navigator, hundreds of miles from land. The sun, your only reliable guide, is gone swallowed by a thick, impenetrable blanket of fog. The stars are a distant memory. You don't have a compass, you don't have a map. Your crew is looking to you as the cold waves crash against the hull, a constant reminder of just how alone you are. Getting lost out here means dying, but you're not worried. You reach into a small leather pouch and pull out a small, plain-looking crystal. A stone that the sagas claim can show you the sun even when you can't see it. Was this legendary solar stein, the sunstone, a real piece of technology, a secret weapon that let them conquer the North Atlantic? Or is it just a myth? Archaeologists have been looking for centuries, but they've never found one in a Viking shipwreck. So, what's the truth behind the Vikings' lost navigation stone? The mundane before the magical, a navigator's toolkit. Before we go chasing the ghost of the sunstone, we have to understand the world of a Viking navigator. Their success wasn't about one single magical gadget. It was built on a foundation of deep, hard-won knowledge, mix of sharp observation, memorized lore, and a few practical, if basic, tools. And if you think that sounds simple, you're seriously underestimating the genius of these seafarers. They were masters of reading the world around them, squeezing every last clue from the sky, the sea, and the life within it. Their first and most basic technique was, of course, just hugging the coastline. For a lot of trips, especially around Scandinavia and the Baltic, the easiest way to get from A to B was to keep land in sight. The Vikings had a mental encyclopedia of the coastlines they traveled, knowing the shapes of fjords, unique rock formations, and the silhouettes of mountains. They passed down detailed sailing directions, which basically said things like, sail west from Herner in Norway for 7 days, and you'll hit the Horn of Iceland. It was simple, it worked, and it was pretty safe. But the Vikings didn't become legends by staying close to shore. Their defining moments were the huge open water crossings to the Faroe Islands, Iceland, Greenland, and beyond. Out there, with no land in sight for days, they had to look up. Celestial navigation was their go-to. On a clear day, the sun was their compass. They knew its arc across the sky. At midday, the sun is at its highest point, which in the northern hemisphere tells you where south is. By watching the length of a shadow cast by something on the ship, like the mast, they could stay on a chosen line of latitude. If they were sailing west from Norway to Greenland, for instance, they needed to stay on roughly the same parallel. They could check this by making sure the midday shadow was always the same length. A shorter shadow meant they drifted south. A longer one meant they'd strayed north. At night, the sky became a different kind of map. The North Star, Polaris, was their anchor. It stays almost perfectly still in the sky, a fixed point marking true north. By measuring how high Polaris was above the horizon, a good navigator could get a solid idea of his latitude. This dependence on the sky was so total that Old Norse even had a word for being lost at sea, hafila, which literally means bewildered at sea, a state the sagas describe as happening when clouds block out the sun and stars. But what happens in the high northern latitudes, the Vikings' main stomping grounds, where conditions are rarely ideal? During the summer, the sky barely gets dark. The midnight sun washes out most of the stars for weeks. Even worse is the North Atlantic's notorious weather. Fog and thick clouds aren't just a possibility, they're a regular feature. On a cloudy day, the sun is just a useless glow, casting no shadows. In the fog, it's gone completely. The celestial map is wiped clean. This is when conventional navigation fails, and a crew becomes truly hafila. To survive these moments, the Vikings turned to their incredible knowledge of the natural world. They were sea ecologists. They watched the flight patterns of birds. A flock of gannets heading out in the morning meant land was in one direction. Their return in the evening pointed the way back. They even carried caged ravens. When they thought land was near, they'd release one. If the bird circled and came back, there was no land in sight. If it flew off in a straight line, the ship followed, trusting the raven to lead them to shore. This is famously how Floki Vilgerharson was said to have discovered Iceland. They also followed whales. Some species have predictable migration routes that often run along coastlines. Spotting a pod could lead a crew toward a landmass. They learned to read the sea itself, the color of the water, the type of seaweed, even the wave patterns could hold clues. A navigator might feel a subtle shift in the ocean swell, a sign that the waves were bouncing off a distant, unseen on the wind. This whole suite of techniques is a staggering mental achievement, blending astronomy, biology, and oceanography. Yet, every method had its limits. Birds are only useful near land. Whales can go off script, and all of it could be made useless by the one thing the North Atlantic has plenty of: thick, relentless cloud cover. It was in these moments when all other methods failed that the Vikings might have reached for their most mysterious tool. And it's here that the line between fact and legend gets blurry.
Unpacking the legend. The Solarstein and the science of seeing the sun. The Solarstein, or sunstone, shows up in history not as a scientific instrument, but as a whisper in the sagas, the epic tales written down in Iceland long after the Viking Age ended. These texts are a messy blend of history, myth, and poetry, so separating fact from fiction is tough. But in these stories, the sunstone appears with a very specific, practical purpose. The most famous mention is in the saga of King Olaf from the 13th century. On a snowy, overcast day, King Olaf wants to know where the sun is. The saga says, "The king made them fetch the sunstone. He held it up and saw where a ray of light shone from the stone, and thus he verified Sigurd's prediction." For centuries, historians dismissed this as pure folklore. A magic stone that finds the sun? Seemed like fantasy, but what if the sagas were describing a lost technology? In 1967, a Danish archaeologist named Thorkild Ramsku proposed that the sunstone wasn't a myth, but a specific type of crystal with a weird property: polarization. The best candidate, he argued, was a mineral found all over Scandinavia, a superclear form of calcite called Iceland spar. To understand how Iceland spar could be the sunstone, we need a quick physics lesson. Sunlight travels in waves, and those waves vibrate in all directions. But when sunlight hits our atmosphere, it scatters and gets filtered. This process organizes or polarizes the light, forcing many of the waves to vibrate in the same plane. This creates a pattern of concentric rings of polarized light in the sky, centered right on the sun, even if you can't see it. Our eyes can't detect this pattern, but a device that can would see a giant compass pointing to the sun. That's where Iceland spar comes in. It's a natural polarizer with a property called birefringence, or double refraction. When a ray of unpolarized light enters the crystal, it splits it into two separate rays. If you look through a piece of Iceland spar, you see a double image of everything. This doubling is the key. Imagine putting a dot on top of the crystal. Looking up from below, you'll see two dots. Now, hold it up to a cloudy sky and rotate it. The brightness of the two dots will change. As you turn the crystal, one dot gets darker, the other gets brighter. There is only one exact angle where the two dots have the same brightness. When that happens, the crystal is aligned with the hidden polarization pattern. It's pointing directly toward the sun. A Viking navigator wouldn't need to know the physics. He just needed to know the rule. Turn the stone until the two dots look the same. Experiments show this method can find the sun's position to within a few degrees of accuracy, even in fog or right after sunset. So the saga's ray of light could just be a poetic way of describing the moment the crystal aligns and one image brightens. The magic was just a repeatable trick of nature, and Iceland spar isn't the only option. Other minerals like cordierite also have polarizing properties. The science is solid. The raw materials were available. Modern experiments have proven these crystals can do exactly what the sagas claim. We have a legend and a lab-tested explanation. All that's missing is the smoking gun, the archaeological proof, the hunt for evidence, the gap between text and trench. For all the convincing science, there's a frustrating reality. No archaeologist has ever pulled a crystal from a Viking shipwreck and declared, "This is a sunstone." Not one has been found in a Viking grave or settlement. This glaring absence is the biggest argument against the sunstone. If these tools were so vital, where are they? Critics argue they should be as common as other finds like swords or axes. Perhaps the saga references are just symbolic, a metaphor for a king's divine wisdom, not a literal navigation tool. Another possibility is that we're just not recognizing them. A clear piece of Iceland spar could become milky and opaque after 1,000 years in a shipwreck, easily mistaken for a worthless rock. Or maybe they were incredibly rare, precious heirlooms passed down through generations, making the odds of finding one astronomically low. For decades, the debate was stuck right there. Then, in 2002, a discovery off the coast of Alderney, one of the Channel Islands, shook things up. Divers exploring a sunken Elizabethan warship from 1592, centuries after the Viking Age, found a small, whitish crystal. It was discovered less than a meter from a pair of navigational dividers. In 2013, scientists confirmed it was Iceland spar. This is a huge deal, even though it's not Viking. The ship had magnetic compasses, but the ship's iron cannons could throw them off. The Alderney crystal was likely used as a backup to find the true position of the sun and double-check the compass reading. This proves that European sailors were using this technology. And if 16th century English sailors were doing it, it's much more plausible that the Vikings could have figured it out hundreds of years earlier. And there's another piece of circumstantial evidence, this one from the right time period. In 1948, an archaeologist found a fragment of a wooden disc in a Norse settlement in Greenland. For a long time, it was dismissed as a decoration. But later researchers identified it as a potential Viking sun compass. A pin in the center would cast a shadow across carved lines, allowing a navigator to find the cardinal directions. But a sun compass only works when the sun is casting a shadow. On a cloudy day, it's useless. This has led many to believe the sun compass and the sunstone were two halves of a single system. First, use the Iceland spar to find the sun's hidden position. Then, use that information to align the sun compass. Together, they create an all-weather navigation system. The Greenland sun compass is a lock. The sunstone is the missing key. While we still don't have a sunstone from a Viking site, the Alderney crystal and the Greenland sun compass build a powerful circumstantial case. We have proof of the technology being used later, and a Viking Age gadget that needs something, like a sunstone, to work fully. The gap between the stories and the science is starting to close. The evidence is all here. The sagas tell us a story, science gives us a plausible mechanism, and archaeology offers some tantalizing indirect clues from a sunken English ship and the ruins of Greenland. But the final verdict is still up for debate. So now I'm turning it over to you. Based on what you've heard, what do you think? Was the Sunstone a real piece of lost Viking tech that powered their expansion across the Atlantic? Or is it a legend that's just too good to be true? Let us know your verdict in the comments. We want to know what you think. The verdict. So, where do we land on the Sunstone? We started with the mystery of how Vikings managed their incredible voyages and the legend of a magical stone. We've seen their conventional toolkit of stars, birds, and waves. We've looked at the physics of polarized light and proved that Iceland's spar can, in fact, find a hidden sun. And we've hunted for physical proof, a search that led us to a 16th century English warship and a fragmented wooden disc from Greenland. We're left with a collection of powerful, interlocking clues. The Icelandic sagas provide the story. Modern science shows it's possible, and while we're still missing a sunstone with Viking navigator written on the side, the indirect evidence is highly persuasive. The Alderney crystal proves the concept of a polarizing crystal as a navigational tool was real in post-medieval Europe. The Greenland sun compass is a Viking Age device that becomes infinitely more useful when you pair it with a sunstone. Because of all this, it seems very plausible that the sunstone was fact, not just folklore. The lack of direct proof isn't necessarily proof that they didn't exist. Considering how easily calcite can be damaged by the sea and time, it's not totally surprising that none have been found. The convergence of evidence is just too strong to ignore. The Solarstein was likely a real and brilliant piece of lost technology. Its memory kept alive in the poetic language of the sagas. This reframes how we see the Vikings. They weren't just the one-dimensional raiders of pop culture. They were explorers, innovators, and keen-eyed practical scientists. They didn't need to write down the physics of birefringence to figure out that a certain crystal, held just right, pointed to the sun. They learned by doing. The sunstone represents the peak of that mindset. A technology pulled from nature itself, a simple, elegant solution to a life-or-death problem. The truth behind the lost navigation stone isn't just about a crystal. It's a story about the incredible ingenuity of the people who used it to master the cold, grey seas and sail straight into legend.